In this video, we're going to take a look at properties. So as we saw already, matter is anything that has mass and volume. And in chemistry, we like to describe matter. To describe matter, we use what's called properties. So it's a characteristic that describes a substance. So it could be, for example, color, how something reacts, the taste, the smell, the hardness. And let's just take a look at some examples, more specific examples. If we're looking at, let's say, gold, pure gold, and we're going to compare that to iron. These are both metals. Gold, one of its properties is that it's yellow in color. And if you were to analyze its hardness, we'd see that gold is actually very, very soft. Iron, on the other hand, is silver in color. And if you were to analyze its hardness, you would see that it's very hard. And so those are just some characteristics used to describe these metals. And these characteristics in science, we call them properties. So what we're going to do in this presentation is take a look at various examples of properties to describe substances. Another important thing to consider here is that even though gold and iron are both metals, they both have different properties. They have different colors, they have different levels of hardness, they have different reactivity, if I were to study that in more detail. And the reason that is because they're made up of different types of particles. So the particles of gold, which are essentially atoms of gold, Au, are different from the particles of iron, which are particles of iron, Fe. So the properties of the big stuff that you see um, really come from the properties of the atoms that they're made up of. And so keep that in mind as we go through this lesson. To describe matter, we can use two types of properties. We can use physical properties and we can use chemical properties. For this lesson, we're going to focus on physical properties, which are essentially just characteristics that will describe a substance without having to change what that substance is. So we can measure it without changing that substance. I can look at something and say, well, that carrot is orange. I didn't have to do any real tests to figure it out. I didn't have to do any reactions to figure out a property that it's orange. I could just look at it and I didn't have to change that carrot to tell you that it was orange. So we're going to focus on physical properties, but there are also chemical properties, which essentially describes how a substance changes. What does it react with, for example? So if I have a metal and I put it in acid and I see that they react, well, I can say that that metal is reactive with acids. So chemical properties, they're different in that when you have to describe or figure out that property, you need to do some kind of test that changes the substance you were dealing with. For me to figure out that the metal was reactive with acid, I had to throw the metal in the acid, and then there was a reaction. Now my metal was transformed or turned into some new substance. So describing something with chemical properties requires you to change that substance to figure out what that chemical property was. So let's start with physical properties, some examples. Usually the easiest one, if you're in a lab, when you're describing a substance, is color. Just what color is it? So this over here, we might say this coin is gold in color or a yellow in color. Sometimes some substances don't really have a color. So for example, water. If there's no color, like in water, we would say it's colorless. Colorless. So water is colorless. Students often like to say that the color of water is clear. Clear is not a description of color. Clear is the fact that you can see through it. Water really doesn't have a color, so we say colorless. So color, what color is it? Very straightforward. Another physical property you can look at is something called the luster. And so luster refers to if something is shiny or dull. So this coin over here is shiny. Now, in science, a word we use rather than shiny is we use the word lustrous. Lustrous. Whereas if something is not shiny, rather than say not shiny, we would say dull. So we would say dull. So the concrete over here is not shiny, so instead we say that it's dull. And oops, I believe I've spelled lustrous wrong here. Lustrous is O-U-S. So let's just cross that out there. This coin is lustrous. And so in the lab, if you're describing metals, for example, many of them are shiny, so you could say that the metal is lustrous. If you were describing a non-metal, many of them are are not shiny, so you could say it's dull. Another physical property you can discuss is conductivity. How well does that substance conduct heat or electricity? So if we look over here, we have copper wire. Copper wire is a good conductor of electricity. Electricity flows through it very easily, so we would say it's a conductor. That's the term we would use to describe its conductivity. Whereas if we look at a fur coat is really good at trapping in heat. And so it does not allow heat to pass through it very easily, so it's not a good conductor. We would call that an insulator. Or if you had rubber, for example, rubber does not let electricity go through it, so it would be more of an insulator as opposed to a conductor. So that's another physical property you can use to describe substances that you're studying in the lab. We'll come back to density after. I just want to go to ductility right now. Ductility is the ability to take a substance and to stretch it into a wire. So copper, for example, copper metal, you can take that substance and you can stretch it to make a wire. And so if you can do that to a substance, that substance would be called ductile. That property is ductility. Copper is ductile. Another property you can discuss is malleability. Malleability is the ability to pound something or roll something into sheets without it breaking. So if you've ever played with aluminum foil before, you could flatten that into sheets and it won't break. So aluminum foil would be considered malleable. So if something has high malleability, we would say that it's malleable. So aluminum is malleable. Play-Doh, for example, is malleable. The opposite of malleable is essentially brittle. So let's say you have a glass. If you drop that glass, it shatters. And so that substance, if you can't roll it or pound it into sheets and it shatters instead, we consider it brittle. Another physical property you might use to describe substances is viscosity. And it's just the resistance to flow. So if something flows very slowly, like let's say maple syrup, we would say that it's viscous. So maple syrup is viscous, or ketchup is viscous. Clarity is another physical property. And it refers to how easily you can see through something, and that relates to how easily light can pass through it or not. Uh, But if you're describing clarity, for example, if I look at this bottle here, I could describe various things with it on it right now in terms of properties. I could tell you its color. Its color is green. Well, there's other colors there too. There's blue, there's red, and there's white, but it's green. And I want you to get that you can see through it. And so the fact that you can see through this quite well, actually, very clearly, makes this bottle transparent. So when I say transparent, that means I can see through it very easily. There's other terms you can use to describe clarity if you cannot see through something. So let's say you put your textbook in front of your eyes or a binder in front of your eyes that you can't see through. That thing would be called opaque if you're describing its clarity. And there are some substances that you can see through them, but not very well. They distort the image quite a bit, and that would be called translucent. And so on the next slide, we'll take a look at an example of each of these side by side. So over here, this glass is transparent. You can see through it very easily. This here is opaque. You cannot see through it. And this door over here is translucent. So you can see through it, but you only see the person's silhouette, for example, like frosted glass. So it's not opaque, it's not transparent, it's somewhere in between. And so these are terms that you can use to describe the clarity of a substance when you're studying them in chemistry. Other properties, physical properties, include melting points, boiling points, and freezing points. Those are all actually physical properties because they don't change the substance. So water will evaporate at 100 degrees Celsius at its boiling point, and that counts as a physical property. Or it melts or freezes at 0 degrees Celsius. Those are melting points and freezing points, also considered physical properties. Then we get to density. Density is essentially how much mass there is for every unit of volume. So density is how much mass there is for every unit of volume. So let's say you have something very small. So let's say it has a very high mass and a very small volume, so it doesn't take up a lot of space. This would be very, very dense. So something deceptively small, like a bowling ball, for example, it's small, fairly small compared to a very large beach ball. So bowling ball is very small, but it's very heavy. So there's a lot of mass in that small amount of space. It would be very dense. The beach ball we saw in the previous lesson was took up a lot of space. It had a large volume, but very small mass. So not a lot of mass in that large space, not very dense. At the most basic level, though, something that's less dense will float on top of something that's more dense. So ice is less dense than liquid water, and that's why it floats above it. But density is a physical property as well. We often measure it in units of grams per mil, because it's mass per unit of volume, or for example, grams per cubic centimeter, because again, this is a mass unit and a volume unit, and it's just describing the amount of mass in that amount of space. As I mentioned before, brittleness is the opposite of malleability. So brittleness is the opposite of malleability. It's the ability of a substance to break into or shatter into pieces. So glass, if you drop that, it's going to shatter into many pieces. Or chalk, if you drop chalk, it shatters into pieces. So it's rather brittle as opposed to being malleable. Another property you can use to describe substances in the lab is the odor, essentially how something smells. So here you can see somebody smelling a substance in a test tube. So let's say that was vinegar. We could say the vinegar has a pungent odor. In grade 12, if you take grade 12 chemistry, you'll learn that you'll get to prepare some substances that have very interesting odors, like they smell like mint, banana, orange, and so you could describe their odors as such. Notice this person is wafting rather than inhaling the fumes, right? You waft the some of the particles towards your nose, providing that you're allowed to actually smell the substance. You always want to read the safety ahead of time. If something does not have an odor, we say it's odorless. So, for example, water doesn't have an odor, so we can say it's odorless. Another property you might use to describe substances in the lab is the taste. Well, not in the lab. That's something you might use in the kitchen when you're cooking, when you're eating, but you wouldn't use this in the lab because you don't taste chemicals in your lab. But they are nonetheless physical properties. So something can taste sweet, sour, salty, bitter. Those are all physical properties that you can use to describe the substance that you're studying. But again, you wouldn't do that in the lab because it's not safe. Even if you're dealing with a lemon in the lab, you really shouldn't eat it. You can also look at the form. So the form could be something as a powder or a crystal. Usually, you might have a magnifying glass to zoom in to view the structure more closely. So, for example, we can see cornstarch over here as a powder, whereas if you look over here, we have salt, NaCl. It has a crystal structure. We can say a crystalline structure, and that's also another example of a physical property. Physical state also counts as a physical property. So if something's a solid, liquid, or a gas, so the cornstarch is a solid. Solubility. If something dissolves, so if I put salt in water and I stir and it looks like it disappeared, it didn't really disappear, it just hid within the water molecules. If something dissolves, we say it's soluble. If something does not dissolve, we say it's insoluble. Insoluble means it did not dissolve in the water, for example. And just a couple terms of review. Remember, the thing that you are dissolving would be the solute, and the substance that's doing the dissolving, that is dissolving the substance that you put in, would be called the solvent. So, for example, when I put my sugar into my coffee there, we can say that the coffee or the water coffee is the solvent. And the sugar is a solute because the sugar dissolves in the coffee. And we could say here that the sugar is soluble since it dissolved in the coffee. In reality, the water is the solvent, and all the coffee um, uh, grinds and flavors and particles and the sugar, those are all the solutes. You can look at texture as well. If you're allowed to touch substances in the lab, because sometimes it's dangerous, so you wouldn't. You could describe something as being smooth, as being rough, like sandpaper, for example, is rough. You could also look at the hardness. This sponge is soft. Now, hardness actually refers to ability of a substance to scratch something. So, for example, let's say that I have a substance. Let's call it substance A, and it can scratch my nail on my finger. So let's say I just try to scratch my nail with the substance and it actually leaves a scratch mark. Then I would say that A is harder than my nail. Let's say that my nail can scratch substance A, then I would say that my nail is harder than substance A. So hardness actually refers to the ability to scratch stuff. And there's actually a scale that was created where you can kind of place an object. And so a level 10 hardness means it can scratch anything below it in levels. So level 10 hardness can scratch level 9, can scratch level 8. And so that was determined by experimentation. And then here, of course, if we're talking about Justin Bieber's cologne, and we say it smells like Justin's sweat, what physical property are we describing there? Hopefully, you know that's an example of odor. So by the end of this lesson, hopefully you understood that we can describe substances using properties. There's two types of properties, physical properties and chemical properties. We went through a whole bunch of physical properties, and so when you do labs, you should be able to describe those substances using a variety of different physical properties.